So this is a basic introduction to probability, and this is the last section before the quarter ends, all right? So please pay attention, write down notes, write down the questions, answer the questions, and write down any questions that you guys might have, all right? So probability is the likelihood of an event happening, all right? So the formula for finding the probability is this right here. So for instance, if we're finding the probability of A, it would equal the number of outcomes in which A occurs divided by the total number of possible outcomes, right? And that A will always change. It can be the probability of B or C or D or whatever, but it's not always going to be A. Some rules that you guys will need to write down and will need to understand are these. The first and very most important one is the probability of A or anything happening is always going to be between 0 and 1. If you have something bigger than 1, as in the probability of A is equal to 2.5, that's never going to happen because your probability is never going to be above 1. So think of this as 100%, right? This right here is going to be your 100%. You can't get more than 100%, especially on a test, unless I give you extra credit, which forget about it. But you can't have more than 100%, so if you get more than 1, it's going to be wrong. All right, you got to do it over again. You got to calculate something better. I don't know. The second rule is the probability of the null set. And hope you guys remember the null set is something that can never happen. So for example, if we were to roll a 7 on a die, which can't happen because it's only 1 through 6, right? That probability is always going to be a 0, right? That event can never actually happen. The probability of the universal, and this is the universal, not the union, not this. This is a different U from that. The universal is everything happening. So remember, if you had your Venn diagram, we had our circles. The universal is all of this happening, which is going to be equal to 1, right? Same as that. That's going to be the exact same number, all right? So for instance, rolling a 1, 2, 3, 4, 5, 6 on a die will always happen no matter what you roll. It's always going to land on one of those numbers. So that's going to be 1. The last one, and I'm going to go over this again later on, but is if A and B are both subsets of U, the universal, right, and are mutually exclusive, then the probability of A, and this is union, right, or A or B is equal to the probability of A plus the probability of B, all right? In this, and I will explain a little bit more later on, mutually exclusive means that no elements are in common. So A intersect B, right? Intersection, which is the same thing as the and, right? From our Venn diagrams before. A and B happening, not going to happen because these never intersect, never overlap. So they have nothing in common. So let's look at a really simple example. From a jar containing 3 Snickers and 2 Kit Kats, 1 piece of candy is drawn at random. What is the probability of the candy selected is one of these, all right? So if you think we have a jar, I know it looks like a fishbowl, but we have 3 Snickers, so I'm going to put S, S, and S, and then we have 2 Kit Kats, so I'm going to put K, K. So we're looking at the probability of something happening when you stick your hand in the jar and you pull out 1 piece of candy, all right? So the first one for A, we're looking at the probability of Snickers, of pulling out a Snickers the first time, right? So again, the number of Snickers that we have, right, number of S, divided by the total number of, let's say, candy, all right? So the number of S is 3, right? We have 3 Snickers, divided by the total number, which is 1, 2, 3, 4, 5. That's going to be your probability of pulling a Snickers out of the jar. Number 2, or letter B, what is the probability of pulling a Kit Kat out of the jar? So again, the number of Kit Kat divided by the total. All right, so the number of Kit Kat, we have 1, 2, so it's 2 divided by the total again, which is 5. So this is the probability of getting a Kit Kat out of the jar. C, the last one, what is the probability of getting a not Snickers? And this is not. All right, not Snickers. In this formula, I'm going to go over again one more time later on. But to find this out, all you have to do is take the universal, which is 1, minus what you already found probability of S, and that will give you the answer of not. So 1 minus 3 over 5 will give you 2 over 5, and this is the probability that you will not pick a Snickers, right? Which is basically the same thing as that. So though that was a very simple example, what we're going to be dealing with are multiple events, and when we deal with multiple events, we need to be careful and we need to list all the outcomes just so we know and just so we visually see what's actually happening. All right. Two ways of doing this is using a tree diagram and then a Venn diagram. All right. So I'm going to go over the tree diagram first. So we use a tree diagram when we have the probability of 2 or more events happening when one event follows the other event. All right. So in this example, we toss a fair coin 2 times, right? So we have the first toss followed by the second toss. So the reason why we use a tree diagram is so that you can see all the different combinations. All right, and I'm going to write combo for the different combinations that we can have. So say the first toss you toss a heads, then the second toss you can get another head, which, sorry, I don't know what's going on with my pen, but you can get another head, right? Or the first toss you can get a head, and then the second toss you can get a tails, so I'm going to put HT. Or in this part, you can do tails and then heads, and this is another combination, and then tails, and this is another combination, right? So in all, we have 1, 2, 3, 4 combinations. I'm going to write 4 combos. All right. So using this information, this tree diagram, and again, this is important because you get to see what combination you get every single toss. All right. What is the probability of exactly 2 heads happening when you flip the 2 tosses? Right. So the only time that's actually happening is this one right here, right? Exactly 2 heads happening. It's only going to be this combo. That's 1 out of the 4. So our probability of that happening is 1/4. What is the probability of at least 1 head happening? All right. So here you have to remember that it's at least 1 head. So it can be 2 heads or it can be more, but in this case only 2, right? So here this is at least 1. This is at least 1. This is at least 1. But here there's 2. So this also counts. So that's 1, 2, 3. Out of 4 combos, this is going to be your probability of at least 1 head happening, right? So again, this at least part is very important. You got to read that carefully. It can be 1 or it could be actually 2, right? So please read that carefully. This is a very basic tree diagram. I'm going to go over, I guess, a harder one later on, but this is how you set this up. The next part is the Venn diagrams, and you guys have seen this before already, but when we're dealing with probability, the rectangle must all add up to 1, as in the universal equals 1. And I don't know why it keeps on doing that. Sorry, you guys. But the universal always equals 1. All right? So if we were to look at this, the intersection A and B, right? A and B is the probability that both A and B occur at the same time, and that's the inside. And the reason why I give you guys these Venn diagrams is you guys are going to have to make these Venn diagrams using the probabilities. And if you guys know what the probability they're asking for, as in the shaded region, then it's a lot easier. So please write these Venn diagrams down or draw these Venn diagrams. The union, A union B, is the probability of A or B or both occurring at the same time, right? And this equation you guys have seen before. And I don't think you actually have to memorize these. This will be on the formula sheet, but you gotta need to know how to use it. So again, the probability of A union B is all the shaded region right here. So this number plus this number plus that number. A complement, which we did before, that is the probability that event A does not occur, right? So if this was A, we want to look at everything outside of A. And note that, remember, the universal is equal to 1. So if this was A, all we had to do is take 1 minus the probability of A, and that will give us a complement. Disjoint, mutually exclusive. Basically, A and B do not touch, so there is no intersection, right? There's no intersection. But A union B, A or B, is that P, whatever probability of A happening is added to whatever probability of B happening, right? And again, please write these down and have these in front of you, so when you guys do the Venn diagrams, you guys know what the questions are asking. All right, so let's look at a very basic example of a Venn diagram problem. Here we have the probability of A is 0.6, probability of B is 0.3, and the probability of A intersect B, right, A and B, is 0.2. So from every diagram or Venn diagram, we only start with the middle. So this gives us the middle number, so we're going to put 0.2 right here, right? To find A, we know that A is 0.6, but we already have the middle part, the intersection, which is 0.2, so we know that 0.4 will go right here. So this is going to be 0.4. 0.3 is for B. We already know we have 0.2 in there, so we have 0.1 left over. That's going to be right here, right? So again, the universal equals 1. If 0.4 plus 0.2 plus 0.1 is A union B, and I'm going to write that down right here, the probability of A union B happening, and that's all of this right here, is going to be 0.7. We know that the outside number is going to be 1 minus 0.7, which is equal to 0.3, and that's going to be the outside. All right. Hopefully you guys understand this part. This is very similar to when I give you guys the middle number and you guys found out the rest. Same concept. All right. So from that, we're going to answer a couple questions. Here it says, what is the probability of A union B? We just found that it's going to be 1 minus 0.7, which is 0.3. What is the probability of B complement, B naught, right? And if we were to look at that, maybe I should draw a Venn diagram. Let me show you an example. So this is the reason why we draw the Venn diagrams, just so it's easier to understand, right? So we have A and we have B, we have the universal. So we want B complement. So everything outside of B, so wherever the red line touches, that's what we want. So that we know from up here, we have 0.3 and then 0.2, or what was it? 0.3 and 0.4. So 0.3 plus 0.4, that will give us B complement, which is 0.7. All right. What is the probability of A and B complement happening? So again, let's draw our diagram. This is what we need. A and B. So we want A. So the probability of A happening is this right here, right? The probability of A and not B, so everything outside of B, and I'm going to draw it the other way or shade it the other way, so everything outside of B. All right? And so the important thing is that you have to see where, because we're looking at and, you have to see where they crisscross, and where the only time that the blue and the green actually crisscross is right here. And this is the only answer. This is your answer right here. Wherever the numbers or the lines crisscross, that's what we're looking for. So in this case, it's only that part in A, which is 0.4. So this is going to be 0.4. With this stuff, the more practice you guys have, the easier it gets. So please write this question down, and we'll have more about this in class. All right. All right, so in this example, we have a Venn diagram listed for us in the information right here. In a class of 20 students, 14 participate in sports, 9 play in the band, and 5 do both. So I labeled here S for sports, and well, I don't know why I put 9, but it should be B, sorry. And B for band. So they tell us the information. We know that 5 do both. That's what we start off at, so 5 should be right here. We know that 14 participated in sports, so 14 minus 5 gives us 9, so we know that 9 is right there. 9 played in sports or band, so 9 minus 5, that gives us 4, and that's 4 right here, right? So we know that 9 plus 5 plus 2 or 4 gives us 18, right? And we know that the universal is 20, so 20 minus 18 gives us 2, so there's 2 outside. So let's look at the questions using this Venn diagram. So a student is selected at random. So one student is selected. What is the probability that the student only played in the band? So only played in the band would be only this number right here. So that would be 4, right? But since we're looking at the probability, it has to be out of the 20. So it's 4 out of 20, which is 1/5, which is 20%, right? Either way, 1/5, 20%, same thing, or 0.2 if you want. You could write 0.2. These are all the same thing. It doesn't matter. What is the probability that the student only played sports? And only played sports is right here. So that's 9 out of 20. Sorry, 9 out of 20, and that's 45% or 0.45. All right, same thing. What is the probability that the person or the student did sports or band? So or is going to be adding up all of these numbers right here. All right. So let me write that down here. So that's 9 plus 5 plus 4, all divided by 20, which is 18 divided by 20, which is the same thing as 0.9 or 90%. All right. And what is the probability that the student did neither? So student did neither, you can basically look at your Venn diagram. You already know it's 2. So it's 2 out of 20, which is 1 over 10, which is 0.1 or 10%. All right. Or say you didn't know that that was a 2. What you could have done was take 1 minus 18 out of 20, right? Because the union was this right here. We could have taken 1 minus 18. That would give us the same thing, which is 2 out of 20. 2 out of 20. And that's how we can get our answer. But don't worry about that. If you already have that answer, you're good to go. Rewind and rewatch this part if it doesn't make sense. But if it does, then you're good. And we'll do more example problems in class. All right. So the last thing I want you to write down and try is this tree diagram, right? So this time we're tossing a fair coin 3 times, and I want to know the probability of all of these happening, all right? So write this tree diagram, and again, you guys might have to make these tree diagrams on your own. Some of the questions actually have it for you. All you have to do is plug those in. But write this tree diagram down and find me the probability of these 3 right here. All right, and we'll go over this in class. All right, that's it.